Problem number 4. The Smith family has 4 sons and 3 daughters. In how many ways can they be seated in a row of 7 chairs such that at least 2 boys are sitting next to each other? Well, let's see. Maybe I'll give you a hint first. Think about how many ways that you could have 2 boys sitting next to each other. So, you could have boy, boy, girl, boy, boy, girl, girl. Okay, there's a lot of different ways that you can have the 2 boys sitting next to each other, at least 2 boys. All right, so you have boy, girl, boy, 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 girl, girl. There's a lot of different ways, but if you think about it, there's really only one way that you can arrange them where no boys are sitting next to each other. So, no matter how you arrange them, you're always going to get 2 boys sitting next to each other unless you arrange them boy, girl, boy, girl, boy, oops, girl, boy, right? You have 4 boys and 3 girls, all right? So this is the only arrangement that doesn't work to get 2 boys sitting next to each other. So my hint to you would be to use complementary counting. All right? Complementary counting. All right, so you might be wondering, well, what does that mean? Now, complementary, if I want the complement of something, complement just means, in this case, to complete. Complement. And you notice I spell it with an E. Now there's another kind of complement spelled with an I, which is like, some sort of praise, like, you've got a really nice haircut, or, I love your new shirt, something like that. That would be, a compliment in that sense. But the other kind of compliment just means it's something that completes. So, for example, you probably have heard the word complement when talking about angles. So if I have like let's say this is a 40-degree angle, the complement of that is 50 degrees because it completes a 90-degree angle. Okay? So in this case, the complement of what we want, what we want is to find how many ways we can arrange these kids so that at least 2 boys sit together. And the complement of that is the case where no boys sit together. Okay, so if we have no boys sitting together, that is the complement of at least 2 boys sitting together, because it's like at least 1 boy sitting by another boy. Okay, so the complement is no boys sitting together. All right, and then if we take that and subtract it from the whole, which would be the number of ways we could arrange these kids with no restrictions, then we should get the number of ways that that at least 2 boys are sitting next to each other. All right? Because if you take the number of ways that 2 boys can sit or at least 2 boys are sitting next to each other, and the number of ways that you can get no boys sitting next to each other, and those 2 things should add up to the total number of ways that you can arrange these kids. Okay, because either 2 boys are sitting next to each other or not, right? There's no other case. You either have at least 2 boys sitting next to each other or not. So So let's do that. Let's figure out how many ways we can arrange these kids so that no boys are sitting next to each other. All right, and let's look at this diagram here. So this, in this case, we've got boy, girl, boy, girl, boy, girl, boy. All right, and we have 4 boys. So if we were to place this first boy, we'd have 4 choices to put in this spot. And for the girls, we have 3 girls, so we have 3 choices for this spot. And now we've already placed one of the boys, so now we only have 3 boys left. And we've placed one of the girls, so we only have 2 girls left to place. And then now we've placed 2 boys, so we have 2 boys left. And then for the last girl, we've only got 1 choice, and the last boy, we've only got 1 choice. Okay? So if we multiply all those together, we'll get the number of ways that we can arrange these 7 kids in a boy, girl, boy, girl, boy, girl arrangement. Okay? So what do we get when we multiply those together? Well, let's see. I'm seeing 12 and I'm seeing 12. So 12 times 12 is 144. Alright. So we have 144 ways that we can seat them so that no boys sit together. Alright. So that's part of our answer. So now let's figure out how many total ways we could arrange these kids without any restrictions. So let's see, the number of ways to arrange 7 kids. Well, we would just have 7 choices for the first position, times 6 times 5 times 4 times 3 times 2 times 1, right? And that's just how we would write it as 7 factorial. And so what do we do? What do we get when we multiply all that together? All right. Well, let's see. I'm seeing. Let's see. I told you no calculators. You could probably use a calculator on this one, but I told you no calculator. So let's see if we can do this without a calculator. So I'm seeing, let's see, 12, 24, 24 times 5, that's 120. So that right there is 120. And then what do we have here? Oops, 120. We multiply it by 6, then we have 720. And let's see, so then if we take 720 times 7, we'll get 0, 14, 49, 50. 50, 40, okay? So that's the total number of ways to arrange 7 kids. And then if we subtract out the ways that we could arrange them so that no boys sit together, we should have the number of ways to arrange them so that at least 2 boys are sitting together. Okay, so let's just subtract 144 from 50, 40, and what do we get? We'll get, let's see, 6, this would be 9, because this I had to borrow, this is 49, so we have 4, 8, 9, 6. Alright, 4, 8, 9, 6 is our answer. So that's the number of ways that we could arrange these kids so that at least 2 boys sit together. Alright? And we used complementary counting. So we counted what we didn't want and then subtracted it from the whole. Okay? So, there you go.